I'm Anil Kumar. Let me thank all the viewers and subscribers for watching my videos, posting excellent remarks, and also sharing some brilliant questions. My special thanks to Mr. Thiru, who has been posting many questions. Some of them are extremely difficult to answer. Here is one of those. I would like you to pause the video, copy the questions, answer, and then look into my solution. I will actually provide you with complete concept to solve questions similar to what you see here. So let's begin with the very first interesting question from Mr. Thiru. Two mutually perpendicular chords AB and CD intersect at P such that AP equals to 4 centimeters, PB equals to 6 centimeters, and CP equals to 3 centimeters. Find the radius of the circle. 4 choices are given to you. Now to help you answer, let me sketch at least, provide you with a diagram. So let us say this is the circle we are talking about, and we have two chords which are intersecting. To make it simpler, we'll take perpendicular chords as vertical and horizontal. Okay, so let's say one of the chords is as shown and the other one is kind of like this. So these are the two chords. Now let's say that this is the chord A to B and this is C to D, and they're intersecting at P. What we are also given here is that A to P is 4 centimeters, okay, and P to B is 6 centimeters. So just to, let me make this as A and this as B. Okay, so A to P is 4 centimeters. This is 4 centimeters. P to B is 6 centimeters. And we have CP as 3 centimeters. We are also given that they intersect at right angles. Now you need to find the radius of the circle. So let us say somewhere here we have the center, and you need to find this radius, right? So let me call this center as O and the radius as R. One of these is the correct answer. You can now pause the video, answer this particular question. Now to answer this question, we need to understand many concepts actually. It is not a straightforward question. So first thing we want to know is what is this length, right? Once we know this length, then there is a formula with which we can find what R is. So now these are called the segments of the chord, and these lengths are actually related. So what I will do here is that we'll actually derive related formulas and then solve this question, okay? Now some of you who know all these formulas can actually get the answer and then check the answer at the end of this video, right? So let's look into the relations which are important to understand. So first one is called the segments of the chord theorem. So let's see what this segments of the chord theorem is. Again, I'll just draw a rough circle. And segments of the chord theorem is a general theorem. It is applicable to any chords, right? So if I have two chords here, let's say these are the two chords, and let's say this chord segment is A1, A2. So this is one chord. The other chord shown in blue, let's say the chord segments are B1 and B2. Then according to this theorem, A1 times A2, the product of these two lengths is equal to the product of other two lengths, B1, B2. Right. So for any two chords, this is for any general formula, right? Any chord segments. Now this is a very important theorem which most of the students will know, right? So in my videos, wide is globally washed, so many students may not know this theorem. That's why I'm taking my time to also prove it. Now the proof is not very difficult. Actually, you can just join these points. So you form two triangles, correct? Now in these two triangles, you can see that we have same angles. These are vertically opposite angles. They are same, correct? Also, what we see that these two angles will also be same. Right? Now these two angles are same because they subtend to same arc, right? So you see this arc. So this arc is common to both these angles, so they are also same, correct? Let's name them. Let's say we use them like, let's say A, B, C, D as we did earlier. Let's call this point as P. Okay. Now what we see here is that the triangle APC is similar to triangle DPB. Reason being that the angle APC is equal to angle DPB. This is first thing. This is a vertically opposite angle, right? And angle CAP is similar, I should say equal to PDB. Let me write like this. Because they subtend arc CB, right? Same arc. So that is why they are both same. So they are similar triangles because of AA properties, correct? So of course, when two angles are similar, the third one is also going to be exactly same, correct? So let me use another ink here to show that third one is also sum is. Now these two angles are given across this arc, correct? That's the reason. Okay, now using the similar triangle properties, AP, which is, let me write, AP over PC should be equal to what? Now AP is opposite to this angle, therefore opposite to this angle is P to D. So we'll write P to D. And P to C is opposite to that angle, and opposite to that angle is P to B, right? So we get P to B. Does make sense? So you have to look for similar triangles, which two sides. Now if you cross multiply, we get AP. Let's say AP times PB, cross multiply, right? Equals to PC or CP, we can say PC or CP, right? Let me write this as CP times PD. Does make sense to you, right? So now AP times PB, which is same as A1, A2, right? So this is our segment A1, this is segment A2, right? Equals to B1, B2. Is that clear to you? So that is how we can actually prove it. Okay. So first proof, very important, which we say is a chord segments of chord theorem, which says if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. That is, A1 times A2 is same as B1 times B2. Perfect. Now let's also look into radius relation with intersecting perpendicular chords. Okay, so let me this time sketch the circle on this side. A slightly bigger circle. I need to write a lot of things here. Okay. So we'll have a very similar diagram as we did earlier. So we have two chords. One will take horizontal, the other one vertical and horizontal. Okay. And let us say that these sides are A1, A2, right? So these are your chord segments. This is B1 and this is B2. So these are your two chords. Now the important thing to understand is that where is the center? Well, center of this circle will be at right bisectors. So basically, right bisectors of chords intersect at center. Right, so basically, if I have a right bisector here, let's say this is my right bisector, and for this one, let's say this is the right bisector, then wherever they intersect, that becomes the center of the circle O. Is that clear to you? Okay. Now, we need to basically relate the radius to the chord segments, right? Because we know the chord segments in our example. Okay, now, what we should do is we should find what is this length, right? We need to find basically this length. Okay, so what we know here is that this length here is half of this total, right? So this length is A1 plus A2 divided by 2, right? Because this is the center, perpendicular bisector. So that line is a perpendicular bisector. So it bisects this chord into two equal parts whose length is A1 plus A2, right? Clear? Okay. Similarly, this length here is basically B1 plus B2 divided by 2, since we have the right bisectors, right? Okay. Now, we need this length shown here, that much. How much is this? This is what we need to figure out. Well, clearly, this is also A1 plus A2 divided by 2. Take away this portion. Perfect. Now, what we can do here is to find this particular length, which is A2 minus all this. Correct? So, or we can also say like this. This is also A1 plus A2, right? So, the length which we are interested, let me label this. Okay. We were saying that this is A for us, this is B for us, C. So I'm trying to label this as we had in the original question. Let's call this point as P. Okay. Now in this case, this is midpoint. Let me call that midpoint as M. So what is PM equals to? Length PM will be half minus A1, right? So it will be A1 plus A2 divided by 2 minus A1. Clear? So we could now say this is A1 plus A2 minus 2 times A1 over 2, which is basically equal to A1 minus A2 minus A1, A2 minus A1 divided by 2. Clear? So this length is A2 minus A1 divided by PM. Okay. So we get this length also, which is, okay, let me write here itself. A2 minus A1 divided by 2. Clear? Okay. Now, we have a right triangle, as you can see. We have a right triangle. So in the right triangle, hypotenuse, which is the radius for us, which is O to B. So radius R square will be equal to B to this, which is B1 plus B2 divided by 2 whole square, plus this length, which is PM for us, A2 minus A1 divided by 2 whole square. Clear? Correct. Now let's expand and simplify. So what we get here is b1 square plus 2b1 b2 plus b2 square, and in this case we get a2 square plus minus, this is minus a1 a2 plus a1 square, correct, divided by 4. So we can write 4 as 1 over 4 here. Clear? Okay. Now let me rearrange this. Write this as 1 over 4 times a1 square plus a2 square plus b1 square plus b2 square plus we have 2b1 b2 minus 2 a1 a2. Clear? Now from the chord segment theorem earlier, we know, earlier we did chord segment theorem, right? From there we know the relation that a1 a2 is equals to b1 b2. Is it okay? So 2 times a1 a2, they are equal, so this is equal to 0, clearly. So if you multiply by 2, then also they are equal. So this part is 0. So what we get here is we can just cross multiply. We can say 4r square equals to a1 square plus a2 square plus b1 square plus b2 square. Is that clear? Since that is 0, right? So this is the formula which relates the chord lengths with the radius. So that is how we can actually find the radius. Is that clear to you? Correct? So now we know each chord length, which is a1, a2, b1, b2, their squares, when you add them up, will be 4 times radius square. Now that is the formula which was required, and I hope the derivation is perfectly fine. Correct? Now let's really solve our question. Clear? So basically we derived 2 formulas. One was the relating chord segments a1 a2 equals to b1 b2, correct? Second, we said 4 times r square is equal to a1 square plus a2 square plus b1 square plus b2 square. So you have to remember these formulas to solve any multiple choice questions based on this concept, right? Then it is very fast to do. Now let's look into this. So we basically need to find what PD is. So what we know from here is CP times PD should be equal to AP times PB, correct? So from here CP is 3, so 3 times PD is equal to 4 times 6. So we know this length PD is basically equal to 4 times 6 or divided by 3, which is 8, right? Very simple. So we got one length, which is this length as 8. So we have all these lengths, right? Now we will substitute in the second formula. So this was using the first one. Now using the second one, 4r square, we said 4r square is equal to 3 square plus 8 square plus 4 square plus 6 square. Clear? So we can just add them up. So we get 9 plus 64 plus 16 plus 36 is 4r square. Clear? Now normally you can do it without calculator, but let's do it with calculator now. So we get 9 plus 64 plus 16 plus 36 equals to 125. 125. Okay? So we get r square is basically equal to 125 divided by 4 square root. Within square root we have 125 divided by 4, which is in decimals 31.25, right? So r basically is 31.25 square root. Clear? So the first one is the right option. So that is how you're going to do. You don't really have to use the calculator for these calculations, but that is how it could be solved. So let me summarize the solution. So in any circle, if you have two perpendicular chords, then their chord segments product is constant, right? So that gives you the missing chord segment length. Then the other formula which we just derived is 4 times r square is sum of squares of each chord segment. That gives you the straightforward answer, so it should not take more than a minute to answer now similar questions. Perfect. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching, and once again, thanks to our subscriber for posting such brilliant question. All the best.